Welcome to the presentation Introduction to the CH552G Microcontroller. I'm Altbeer and I'm going to walk you through this presentation. This slide deck is available under altbeer.us/CH552G. So let's start with a simple question. What is a microcontroller? Well, a microcontroller is a compact integrated circuit that's designed to govern a specific operation in an embedded system. Typically, this is the brains of whatever it is you're going to build. And if you seriously didn't know what a microcontroller was before ending up here, this might not be the presentation for you because I'm going to get into the technical details of it. So let's start with an overview. So the CH552 series of chips, they're 8-bit USB device microcontrollers that are MCS51 compatible. They have an E8051 ARM core processor. Their processor supports 24 megahertz system clock speed. It has built-in 16K of ROM, 256 bytes of IRAM, and 1K of XRAM. And the XRAM has DMA support. So the features that it also includes, which I love about these chips, is that in addition to a built-in bootloader, it has a built-in USB controller with device mode. That's probably the most powerful thing about this chip compared to other chips, other than its price point, which is very low. These are cheap chips. They're depending upon the quantity you buy, anywhere from 30 cents down to, like, I got some for 15 cents each. And normally with chips that cheap, you would have to get a secondary chip to support the USB functions, and this has it built in, which I love. They also support PWM. At least 2 pins support PWM on the device. They have a full duplex UART, and they have a SPI communication interface. So they were manufactured by WCH, which I just found out putting this presentation together is Nanjing Kuheng Microelectronics. I didn't know that's who WCH was. But anyway, their website is wch.cn. They're available in several different form factors. So, and there's other CH chips beyond the 552. I'm specifically talking about the 552 series of chips. And they have 3 different form factors for that. And that's the CH552T is in a TSSOP20 form factor. So that means it has 20 pins on it, and it's a really tiny chip. The SOP16 form factor is what the CH552G chip uses, and that's the one that I typically use the most. And then there's an MSOP10, which is the CH552E chip. And I have pictures of the chips here for you to review. Let's talk about the architecture. So regardless of which form factor you're dealing with, all of the CH552 chips share this same architecture. So you can see on the diagram here where the E8051 core is, where the internal address and data buses are, the 8-bit output pins for port 3 or port 1, which are switched ports. So you'll see in the diagrams on the right, when we go to pinouts and you're dealing with certain pins on the box, it might be pin 1.2 or 1.3 because each of these ports, like port 1 and port 3, are switched to allow access to several pins on each port. And then we have it has a watchdog built in. It has an internal oscillator. It has internal capacitive touch, so you can actually use it for capacitive touch applications. But really, the form factor comes down to how many pins are externally available from this architecture. And in my opinion, the G model which is kind of the middle of the road between the three, has the most functionality for its size. So the T is physically a smaller chip with more pins, but I find that it's harder to work with and it's slightly more expensive than the G, because the G is in the form factor it's a slightly larger chip than the T with less pins. It's easier to do manual soldering on it and just to work with it generally. And then the E, while that would be very easy to work with, it just doesn't have the pin density to do major application work. So if you're using it in a design, you would have very limited options as to what you could control with it. So let's talk about the G specifically and its pinout and the boilerplate schematic. So working with the CH552G on several projects, I was able to put together what I'm calling the boilerplate configuration. This is the stuff that I think is like the bare minimum schematic to work with this chip. I created this schematic in KiCad, and it's available on any of the public project repos I have for my projects, which I'll detail later. So the main work that I did was in building this chip. I put in all of the text that was in the documentation on what's on which pin, and then I tagged them, all those interfaces, so that you can easily use them in the schematic and tag them out elsewhere in your diagram. But the USB is probably the most important piece, because this is how you're going to program the chip. So you need a USB interface. And with that USB interface, you also need a way to put the IC into programming mode. Now, I say that, but when the chip comes fresh from the factory, it is by default in programming mode. So you wouldn't need this resistor, this pull-up resistor, to apply pull-up voltage unless you're going to reprogram the chip. So the first time you use the chip and you plug it into USB, even without anything on D plus here, it's going to be in programming mode, and you can push code to it once. Once it has code on it, a firmware loaded, the only way to reprogram it is to be able to do a pull-up voltage on the D plus line, which D plus is pin 3.6 on the chip. And if it gets that pull-up voltage, then it will put the chip into programming mode and allow you to push code to it or firmware to it via USB again. So that's an important note. I consider this a staple of my designs because I reprogram the chips often. So really this schematic just has a 10K resistor with a button that connects to the 3.3 volt output. So I'm taking the 3.3 volts, and only if I push the button will it apply that through a 10K resistor to pull up that voltage on D plus and flag the IC to let it know that it needs to go into programming mode. Some of the other things that I add on here are the capacitors. Decoupling capacitors for both the 5 volt and the 3 volt power lines are really necessary. At a minimum, because the 5 volt power line is used by the USB, you have to have one capacitor on that 5 volt. If you don't have that, there's going to be too much noise on the USB power line, and you're going to have corrupted firmware pushes or anything else you try to do on the USB. The data is going to get mangled up, so it's not going to work well. So at a minimum, you need one on that 5 volt line that the USB is using. I put a decoupling capacitor or suppression capacitor on both of the power lines. And then the other thing that I add, which is optional obviously, is I put in a connector to allow for switching between or for connecting up battery power, and I put a switch to control switching between battery power and USB power. And this is because most of what I use this chip for is projects that use batteries, that they're wearable projects like badges. And so for that reason, I want to be able to switch between USB power, where I'm programming the board via USB, or plugging it in to work with it and change code and whatever, versus battery power, where I'm walking around with the wearable. And by using an on-on switch like this one, I can ensure that I'm never going to have a situation where I'm receiving voltage from battery and USB at the same time, which would overvolt the chip, and it could burn the chip out by doing that. So that's why that's an important feature, I think, and I put it in the boilerplate. So let's talk about how to program this chip. So programming the CH552G, when I first started working with them, there wasn't a whole lot of documentation out there, but I found that the actual ARM chipset, the 8051 chipset, did have documentation and how-tos on how to program it. So when you're doing searches for programming, I would suggest using the chipset and not the actual WCH name for their IC. So Kiel C51 is one of the major programs out there that you can use to program this chipset. And then the other one that I've found is SDCC, which is the Small Device C compiler. Now, Kiel, at least when I researched it, it wasn't free. It had a cost associated with it. So personally, I use SDCC to work with these chips. And the best CH552 SDCC SDK I've found, and that's a mouthful, is from Blinken Labs. What they did was they ported an old CH554 Kiel software development kit over to SDCC. So this includes all of the C header files that we're going to need to work with the chips. And even though it was ported from a 554 chipset, it's still, those header files still work fine with the 552. And so you can find that at the Blinken Labs GitHub site in a project called CH554 SDCC. So now, once you have the C compiler and you're able to compile your firmware, you still need a way to push it to the chip. So WCH has a program, an official program that they use for this, called the WCH ISP tool. And you can download that from their website under, if you go to their website and click Service Downloads, you'll see it as one of the downloads. I would have included the link, but the actual link to the program is so long it would have wrapped twice around the screen, and nobody's going to type all that. So it's easier just to go there, go to Service, and then Downloads. Now, you also have open source tools available to do this same thing, so you don't have to use the WCH program. There's a program called Libra CH551 that works fine for all the 55 chips. And then there's CH552 tool, and their GitHub pages are listed here. Both of those work well on many different operating systems, where the WCH ISP tool is a specific Windows product. Now let's talk about some of the projects that I've used with this chip. So I made the Akira badge for the BSidesDFW 2019 conference, and that was the attendees conference badge. And it had a CH552G chip on it, driving 8 LEDs around the wheels, and it had various programs on there, including a crypto challenge. So that was one of the projects I did recently. And then probably the most recent project was my 84 badge, which was my DEF CON 28, the virtual DEF CON. It was an indie badge for that DEF CON. And so on either of these websites, those are both sitting in the GitHub repos, and you can easily click open repo to get there. You'll see how I perform the PCB design using the CH552 chips. You'll have all the code that I used for both, and the way I'm driving the different components on each badge. Those are all detailed in my project pages and their associated GitHub repos, which are public. So I'm hoping that would help people out. And one of the things that I did for the 84 badge, if you see on the upper left-hand corner here, there's a little development board running a CH552G. This was done as my prep work for the 84 badge project. And within that project repository, in addition to the full badge schematics and design files, you have the development board design file is in there too. So all of those are open hardware, open source, so anyone can reproduce them by just either using KiCad to develop the Gerber files, or I believe I've exported the Gerber files into the repository, so that all you would have to do is download those and upload them to whatever manufacturer you want to make the boards for yourself. So I thought that would be a helpful way to get people into this badge, which I have really gotten excited about, or into this chipset that I've really gotten excited about using on my badges. So let's talk about some projects by others. So when I first got interested in the CH55 line of chips, it was based on a Hackaday story where they were talking about the architecture and the work that Blinken Labs did porting the SDK. But there weren't any projects tied to that particular article. But what really made me decide that I need to start using this in projects on my own was another Hackaday story named How to Program a Really Cheap Microcontroller. And that, I have the link to that article here. That article really detailed the work of someone named Aaron Christoffel, who showed the power of that little chip in a YouTube video. So I have the YouTube video link there. And what he did was, in the video, what I really found interesting and what I liked was the first thing he had to figure out how to do was he bought the chip and he had to figure out how to program it. And so he shows you the strip boards that he hacked to build his own USB interface and the pull-up voltage resistor and all that. He just built that by hand on some little PCB strip boards and soldered the chip and all the components onto that together. And then once he had that little hack done, he was able to design a development board that did that for him. And then he moved from there on to hand-drawn schematics on what he was going to do with the chip. And then moved into code showing how he was driving an IPS display with a SPI bus using the CH552G chip. It really got me excited about working with these chips, and I highly recommend if you're thinking about working with these chips, you check out that video because that was a cool walkthrough of his project. So there's some other projects out there, mostly development boards of some type or another to play with the chips. So the first one that I found looking for different development boards was the CH/USB-IE. Now, I don't know if you're supposed to pronounce it Chusby or not, but that's what I've been doing. And it's a cute little development board, has some component interfaces on it. It has header pin connectors. That way you can use it on other breadboards or projects to play with different things. And then the next one is called the CH552 Dragon. And this project is another development board, but it has a lot of different component connection points on it to where you can add through-hole components and surface mount components onto the board. So I liked that one as well, and I wanted to share that here. And then one of the things that really helped me understanding how to code these boards was a project that I was pointed to by the Badge Life community. It was a project that was written by Rickett7, that's his Twitter handle. He created an electronic business card using the CH552T chip, and he also included a development board for use with that project. So I found his documentation and his firmware to be very helpful in my understanding and usage of the 552 chips. So you can find that project on GitHub under Rickett CH552. Really cool project. And I hope that this was a helpful introduction into the CH552 chips. This was being presented as part of the BSidesDFW 2020 Hardware Hacking Village. There is another presentation related to this chip where I'm going to walk through the SDCC compiler and how to actually push code to one of these chips. So if you're interested, I would suggest you look up that video, and I'll see you there if you decide to take that. Otherwise, thank you for attending, and I hope you learned something.